Hello maths fans, I am Dr. Tom Crawford from Tom Rocks Maths and I am a mathematician at the University of Oxford. Today's Maths Week puzzle was all about Ada. Ada's class were told to form teams of equal size for a Maths Week competition. But the problem was, when they tried to get into pairs, Ada was left by herself. They then tried threes, but again, Ada was the only one left without a team. Groups of four didn't go much better, as once again, Ada was the only person left all alone. But fortunately, when they divided the class up into groups of five, Ada had a complete team and everything worked perfectly. So the question is, how many people were in Ada's class? And here is how I thought about the answer. The first step is to think about what each piece of information tells us about the unknown class size. So the first thing we are told is that when the class try to divide into pairs, Ada is left by herself. So this says that the class size, our unknown number, when you divide it by 2, you have remainder 1. Now if you think a little bit about what that means about our class size, it tells us that it must be an odd number, because we define even numbers to be numbers that are perfectly divisible by 2, and here we know that when you divide the class size by 2, you have remainder 1, which tells you that it's an odd number. Next, the class tried to divide up into groups of 3, and again there was a remainder, a single remainder, which was Ada. So this tells us that the total size of the class is not divisible perfectly by 3, but not only is it not divisible by 3, it's exactly 1 more than a multiple of 3, because we have a single remainder, which is Ada, when we divide the class size into 3s. So that means that the class size must be a multiple of 3, so a number in the 3 times table, plus 1. When trying to divide by 4, we again have the exact same situation. The total class size, when divided by 4, gives you remainder 1, because Ada is again left entirely all alone. So what that means for our rule is that we have a multiple of 4, similar to what we had in rule 2, except now we must be 1 more than a number in the 4 times table. Now the final piece of information is that when the class divide into groups of 5, it finally works. So this means that our class size, our unknown value we're trying to find, must be exactly a multiple of 5. It must appear in the 5 times table. So now we have our complete set of 4 rules. We've used all 4 pieces of information given to us in the problem, and we've written them out in 4 mathematical rules which our answer must satisfy. So now we can start considering possible numbers and see if we can find one that satisfies all 4 rules. To start with, I've just considered the first 30 positive whole numbers, and what we're going to do is use these rules to try and cross off which ones aren't possible and see if we're left with a correct answer. Now, I should say at this point that the answer could be more than 30, but to save me writing out every single possible number, I've decided to start with the first 30, see if we can get an answer. If we can, then great, we've solved the problem, but if we can't, then I'll have to consider higher numbers. But for now, this seems a sensible starting point for a class size. Rule number 1 says that our class size must be an odd number. So straight away, we can just cross off all of the even numbers from our list. Rule number 2 says that the number must be 1 more than a multiple of 3. So that means any number here that's in the 3 times table, we can cross off, and we can also cross off any number that is 1 less than a multiple of 3. So first of all, let's cross off the numbers in the 3 times table. So 3, 6 is already gone, can't be 9. We cannot be 12, that's gone, can't be 15, 18's gone, 21, 24 is gone, 27 and 30 is already gone. So again, we've crossed off some more numbers, and as I mentioned, we also need to cross off the numbers that are 2 more than a multiple of 3, because to satisfy rule number 2, we can only be 1 more than a multiple of 3. So that's going to mean 5, for example, is 2 more than 3, so that cannot be possible to fit rules 1 and 2. So 5 doesn't work. 7 is okay because it's 1 more than 6, which is 2 times 3. So we keep 7. 13 is 1 more than 12, so that's okay, but 11 is not. Going down, 17, that is 1 less than 18, which is a multiple of 3, so that won't work. That has to go. 19 is okay. 23 is going to not be okay. 25 is fine. And then 29 is 1 less than 30, so that doesn't work either. On to rule number 3, we have the same idea. We want to cross off anything that's in the 4 times table, and also anything that is 2 more than a multiple of 4, or 3 more than a multiple of 4. Because by rule 3, we can only be 1 higher than a number in the 4 times table. So 1 is okay, 7 is not okay, because it's 3 more than a multiple of 4. So we cannot have 7. Then we can have 13, I think. Multiple of 4, yes. 12 is 3 times 4 plus 1. That one is okay. Then 19 is not allowed, because that's going to be 3 more than 16, multiple of 4. 25, 4 times 6 is 24, plus 1, 25 is okay, and that's it. So now, from the first 3 rules, we're only left with, I think, just 3 possibilities. We've got 1, 13, and 25. And now the last rule, rule number 4, says that our answer, the class size, must be a multiple of 5. It must be perfectly divisible by 5. So 1 is going to be fail now, 13 is also going to fail, and that leaves 25, 5 times 5, as the only remaining number in the first 30 positive whole numbers. So the answer, satisfying the 4 rules, is going to be 25, and so the class size is 25. Ada's class has 25 people, and that is the solution to today's puzzle.